Some of you might know the eMonitor from the past, or heard about it, or been in contact with us or VEIC. But the agenda for today is I gave you a little bit of background on who PowerWise is compared to Powerhouse Dynamics. We're going to talk about the new eMonitor, but I'm also going to talk about eMonitor as you haven't seen it before. I'm going to mention a little bit the parallel unit we have, the eMonitor C-Series, which is for three-phase small commercial buildings. And then we're going to talk about how we address adding non-electrical monitoring to this particular device. And the good thing is that everything is integrated and really the data is sent to one location, and it's a central gateway that collects all the data from the house. And then we're going to talk about the passive house monitoring solution, the second generation system based on our experience the last almost 2 years. And we could talk a little bit about the future. We also have a session for question and answers. Feel free to type in your questions in the chat mode, and Peter will come back and be monitoring the questions and controlling that. So without bragging, I am the founder of Powerhouse Dynamics, the eMonitor solution. I also co-invented the solution together with another gentleman in Blue Hill, Maine. And as I moved from New York to Maine to live a better life in nature, and that Powerhouse Dynamics investors prefer to move the company from Maine to Boston, I said I prefer to stay in Maine. So I'm still working part-time from Powerhouse Dynamics, but I started my own solution provider / dealership under the name PowerWise, together with the majority of the group of the inventors of the original eMonitor. So we are now a very successful eMonitor specialist and solution provider. We actually, by far, the dealer that have sold the most eMonitor systems in North America. We actually have sold over a fourth of all eMonitors in the world. We are a staff of 7 full-time people and 4 part-time people as well. Our success has, of course, been our focus. We don't sell anything except for things around the eMonitor. We are able, as the people that have created the dashboard design are working for us, and also the database system, so we are able to create many custom dashboards. We have made, I think, 13 custom dashboards for various projects around the country. We are also kind of a resource for Powerhouse Dynamics to add features. We made the weather station integration. We have actually developed the support of the sensors in the gateway is firmware that is done by PowerWise systems. And just as that, you know, it only took a phase when people start, what about other things? What about BTU? What about temperature? And we early on saw that need, and we started with third-party data logger, and now we have just made it all integrated. Our future R&D is also continuing to do more into controls. Right now we do have controls based on a thermostat, but we also have we're working on a Z-Wave radio that would enable pretty much any kind of control. When we talk about passive home, we might be able to enable lines going down based on temperatures and things like that. So pretty exciting stuff in the future. So So the new eMonitor, the first eMonitor was launched in early spring of 2010, and I would like to, as there's many VIC people in the audience here, I'd like to thank VIC for being a good partner in the early beta test of eMonitor in 2009. We had 12 people, all employees of VIC, testing the product for us and gave us good feedback, and is also the reason why we have a strong and very powerful product. We are still, maybe to some surprise, to see that the eMonitor stands out as being the most versatile, most powerful circuit-level monitoring solutions available. We're still looking at competitors and all that stuff, and we don't see anyone that really have a powerful solution in terms of amount of channels, circuit breakers we can add, and now with the added building monitoring, from the competition. We monitor all energy costs in the production. As I said before, the first level of control we have is via the thermostat. This is unusual warm days for us in Vermont and Maine, but many other places in the country, California, Arizona, they're dealing with these temperature good part of the year. So controlling temperature and especially controlling AC with thermostat is one of the biggest control factors in terms of reducing cost. I know Maine and Vermont also have a lot of expensive oil, and also control that, of course, in the heating season. One of the strongest features of the eMonitor is the alerts. It can tell you, based on various conditions, what's going on. You're spending too much money, have you left things on? I like to tell a good old story about one of the first eMonitors we have installed. Somebody, a family, went away on vacation for 10 days, and on the way to the airport, the father gets a text message from his eMonitor saying that the oven is on for the last 2 hours. And it looks like, depending on the wattage, that it's probably on 400 degrees. And he's planned to be away for 10 days. So it turned out that his 12-year-old daughter was making cupcakes and totally forgot about the excitement, because of the excitement of the trip. So it might have saved the house. The neighbor came over and saved the house, but not the cupcakes. But here's a good example of how alerts can also be important for safety. Good. So the eMonitor in a simple form here. So the new eMonitor, basically, the eMonitor sits inside now the electrical panel. And as you might remember from the old eMonitors, we had wires going from the current transformers through the knockout hole and sometimes through sheetrocks and panel walls into the eMonitor that's right next to the panel. Now we made the eMonitor itself, and it is extension parts. You can access the eMonitor from a configuration of 14 all the way up to 44 circuit breaker support. It's inside the electrical panel, and now wirelessly communicating with a Wi-Fi protocol to the eMonitor gateway that can be up between 30 and 50 feet away from the electrical panel, so you can actually have a freedom on where you are placing the gateway. Also, as you can see in this particular picture, that if you have two eMonitors, let's say you have a sub-panel and you have a separate eMonitor in that panel, the same gateway can actually support those two eMonitors, and as long as they both are within 30 to 50 feet of distance to the eMonitor. The eMonitor can actually support up to 10, the gateway can support up to 10 eMonitors. So how it works in a simplified form is that we are taking the energy data, basically the amperage data, every second from each circuit breaker, and via the power supply of the eMonitor, which also gets the power from one of the circuit breakers. We know the voltage, of course, by those two important factors. We know how much watt a circuit breaker is drawing. So we're taking the average data of that, sending to the internet to our central servers, and then we're doing a lot of ongoing queries, analysis. Imagine that we have 24 channels, and every minute we have to see if a channel is overloaded or if a condition is met and all that stuff. So there's a tremendous amount of data crunching going on as soon as the data is uploading. In this diagram, you can also see that we, via Wi-Fi, we can support thermostats, unlimited amount of thermostats in the home, and I will talk about the additional sensors and controls connected to the gateway as well. We have various way of displaying this, of course, online on an online dashboard. Web browser is the most used, but we also have an iPhone app, and hopefully within a few months we have an Android app, and we're also working on revamping our iPad app as well. It's great to see when I came in the reception, I can see that there is a iPad in the reception showing how much data, how much energy VSD is using right now. I won't tell how much I saw on there. Was there a question?
Yeah, how many input ports are there on each eMonitor?
When you talk about input, are you talking about to the...
From each, how many CPs can you connect?
So basically, one eMonitor can support up to 20, up to 44 circuit breakers. Because that's normally, you hardly see anything more than 42 in a panel, then people go to sub-panels. So, and then you can basically add another eMonitor. So we have some mansions that are, I think, have like 400 or 500 circuit breakers monitored. So there's really no limitation. You can say that after that, you might want to group them because it might be a little bit difficult to see 400 channels in a pie chart and get an overview of what's going on in the home. But it is, in theory, it is possible. So this slide here gives a little more detailed picture of what kind of units the gateway or the eMonitor solution support consists of. And the eMonitor itself is that rectangular unit there. And I said it can also come in a form where it actually also have three-phase support. So instead of, there's some pictures here showing 3 CTs instead of 2 CTs for the mains. It's fairly skinny. We have reduced the size quite a bit. Also, we're using a new connector form that actually has 2 CTs in one connector. The expansion part, I said that the exciting thing for the eMonitor here compared to the old one is that we can expand the product. People say, okay, my budget only really allows me to have the starter eMonitor 14. At any time, you can add an extra set of 10 channels. You can have 24, 34, and 44. And it doesn't really cost much more than the difference in price. So there's no penalty for upgrading. The gateway, as I said, is more than a gateway. It's a full-blown data logger. And one thing that is important that we didn't have in the past is that it also have an option to support Wi-Fi. Before it was only a hardwired Ethernet connection. We also have a parallel port, a serial port that can support future things, maybe wired weather stations and other things. Here is just kind of to give you an idea how are the components before they go into the panel. I made this picture here where you see the gateway. In this case, it has a non-Wi-Fi. Of course, the same product, the same gateway can be configured to be Wi-Fi or wireless. But here you see the Ethernet cable here to the left, and then we have the eMonitor here. This is a 3-phase unit with 3 CTs, and then we have the what we call the Modbus cable between the various expansions. So these X parts here can support up to 10 CTs. Close-up of the eMonitors fully equipped with, in this case, 15 circuit breaker monitoring, including the mains. And you can actually see that this particular wire here is what powers the eMonitors inside the panel. One goes to a circuit breaker and the other one goes to a neutral. Again, the beauty we had by moving to this new platform is that we had some difficulties in the past where we had, especially in California, Texas, and also in Arizona, some, I think, places in Florida, there's a lot of outdoor panels. And the fact that we can have the eMonitor inside the panel and have the gateway inside the house, no problem, makes it very easy to support those. And we also, some people actually have electrical panels right in their home, so we're not always happy to see an eMonitor going up through the wall. So that's also nice that you can't really see that after you put the panel cover on. So here again, just to emphasize the modularity of the product, the eMonitor itself, 14 circuits if it's residential, single phase, 15 if it's three-phase commercial, and then the up to 30 extra CTs with these X pods, and then the gateway, which I'll talk much more about in a few moments. So I'll give you a short eMonitor live presentation, but here's some sample of the graphs that it does show. We love this layer graph here that basically shows we can see what a spike consists of at any time. Many of the total house monitoring packages out there will show spikes, but you kind of have to guess what go on. Here we can actually see minute by minute what is making that combined spike. You can see in descending orders what are the biggest power users down to the one that hardly using any power. It's a great tool for monitoring renewables. It does a very good job of your PV power. Also, I just installed a tiny 1 kilowatt wind turbine in my home, and it's fun to see the wind turbine production and the combined renewable production of those two sources. And there's a great history. We have a very elegant, what we could say, remote-controlled thermostat interface where we can actually, we have 4 major time slots defined: the sleep, the wake-up time, being away to work, and then being at home, and of course those compensate for weekends and all stuff. You can put in a vacation schedule and have a calendar where you can actually put in when you're going to be away. You can also, on the way home from work on a cold day, you can take your iPhone and soon your Android and say, okay, let me pump up the heat a little bit in cold Vermont or Maine or other cold places. Or today, let me move the thermostat from 72 to 68. The thing is that the way that the eMonitor can communicate with you is really a powerful tool. You have many ways of setting up things. It can even tell you that you left your refrigerator door open, and which is something that my kids do very often. I sometimes call them when I'm business traveling in California or in Denmark and say, like, why is the refrigerator door open? I was right. But it can have, of course, many more important things that can be monitored as well. So we have text messages you can set up. You can have emails. You can have several email addresses communicating to it with people that have vacation home. They want to have a caretaker and so forth. So that's a way to view that and text message. You can even have somebody. You could actually have an alert being notified on Facebook so that all your friends can know that you left your refrigerator door open. So or Twitter that information as well. So, okay, I'm gonna go fast through these, but you basically, because of the aggregation, you really can see every single circuit, what goes on. So there's always an aha factor of what's going on in the home, and I didn't know that that was going on. It's a good old story about, many homes get this new Energy Star refrigerator, but the old one is not going away. It's going in the den or going in the garage for a couple of six-packs, but who knows that it costs $280 to keep them cold a year. So things like that. Especially when we talk about appliances, we monitor appliances on a load-by-load basis, so we can actually see if there's something wrong with the humidity sensor of your dryer, or something could be wrong with your washing machine and so forth. So it monitors things on a load-by-load basis. We did do a study among 250 eMonitor users in November 2010, and far majority said that they were definitely seeing savings, and it's all the way from 13, 34, and 51%. You can say that, why do you need an eMonitor? When you first have found your stuff, then there's still things that go wrong. Paul Shekel here, after using his eMonitor for 6 months, he saw that he actually found out that he had a defective defrost coil in the refrigerator, and started using 3 times as much power, and he could get that replaced for $20. So it does make sense to keep. One second, let me see if I can jump to, I don't know which, what browser you.
Internet Explorer there.
Okay. So I'm going to run through a demo here. So this is a regular home. I like to say this is my rental home, my own rental home. I have a small TV set up here, and it is sunny in Maine right now. So I can actually see I'm selling back 67 watts to the grid, and I only have 224 watts, so it's probably overcasted in Maine right now. But anyway, I can see this turns red when I'm actually buying power, and it turns green when I'm selling power to the utility via credit. It will tell me in order what is actually on in the house right now. I can click on these and I can see detail what's going on. It will tell me compared to an average home in Maine, what's my carbon footprint. And because I have a small panel and a wind turbine, I'm doing pretty good. I can go in and check my phantom load and say, like, what is going on here. These are the things where you normally plug in a charger. You can see a DVD player or something that is always on. And in many cases, we will recommend people to get these, even just a Christmas-like timer for $7, $8, and just have it. These are now digital for the same price, so you can actually define these should be off at night. And by using 4 or 5 of these around the home, we have seen reduce phantom power up to 60 to 70%. In this particular home, only $70 a year, but I have seen bigger houses where that amount is maybe $600 and $700 and $800 a year. So just with eliminating the phantom power, the eMonitor is very close to be covered in terms of a payback. We go down to the next panel here. We can see a pie chart that shows everything in the home, what's going on here. So we can see that the refrigerator is 22% of the house energy, and it's probably the biggest load. And playroom here, I know that's a entertainment center and Xbox and so forth. So that's using lot of power as well. Just to clearly look at who are the biggest power hogs, so we have like the four biggest one here. When you say propane boiler, that's often we see the go with oil and propane. That the circular pumps normally takes a lot of power of that. It's not just the fans and so forth. I can go in here and then see the total power minute by minute. I can go by week. I can take week production and power. So you can kind of see here that it looks my panel could be a little bigger. But if I want to see, how is my production on a regular basis, I can actually go in and see history details where I say, okay, let me go in and look at my production versus my usage and my utility meter. So I can basically see that the blue is what I have generated, and the brown line is utility meter. So this is on a month basis, and you can see I have the production and the usage data up on top. I can also click on one particular month, and therefore I get it day by day. I can go all the way in to actually see the particular day and dive down and see what happened that day. Here we go. Good. One of my favorite graphs is really to look at the detailed graph of okay, circuit details. So if I would go in and see what the spike consists of. So I don't want to spend too much time on it here, but this is a layer graph, so everything is stacked on top of each other. So let me try to see the most predominant here is the refrigerator. So if I unclick that on the graph, you can see how it changed. So I can actually select certain groups. Let's say in the house I only want to look at lighting and so forth. So I can actually go in and select these. So these spikes here is the dehumidifier. And if I take these away, then you can see again that the graphs are changing. So a pretty powerful tool. As I said before, I can go in and look at all different circuits. The refrigerator is a very typical pattern where we have normally every other day we have the defrost cycle. You see the bigger spikes there, the defrost cycles that happens. I can look at just the washer, so you can see what we have. You can see somebody did a wash yesterday in the morning. You can see that the cost per load and so forth. Very quickly here is the thermostat, and here you can see the actual temperature. There's no air conditioning in this house here, but you can see the actual temperature is the purple graph here, and the set point is the brown graph here. So based on heating, but and the exciting thing here is that it's so easy for you to raise the temperature just by sliding this graph up. And if I want to change the length of one of these before, I can just drag this here. So this is basically an override, and if I go back to the settings, so it will only go back after this graph is done. And from a time point of view, it goes back to the default you set in the settings.
You said just the thermostat, the wireless.
We are basically using a thermostat that is made by a company in by Radio Thermostat of America, and you can actually buy it from Home Depot for around $99, and they will be plug and play with eMonitor, so it's very easy to add that to the system. Good. We'll go back to the webinar. So when we talk about the monitoring other than electricity, the eMonitor gateway is the key device that enables that. When Efficiency Main and PowerWise worked on the first generation passive power solution, we worked with another data logger, and we basically wanted at least the gateway in this new eMonitor configuration to do a majority of what was needed for the passive power solution. And we have, right now, we have 3 digital and 3 analog ports available, and right now we have enabled with the firmware that PowerWise have made for the gateway a one-wire network bus, which really have many capabilities in itself, and then we also have 2 pulse counters for flow meters, which can be liquid water, glycol for solar hot water system, but also natural gas and propane. The eMonitor gateway is a very elegant and fine device, and we opt from what I put my Powerhouse Dynamics hat on. We didn't want to make it too complex and beef it up too much. So in order to really have full use and also get power to the one-wire network bus in general can support by itself the temperature sensors and a few other sensors, but any other device on the one-wire network bus needs to have an external power. The eMonitor gateway does not give the power, plus that it can be a little difficult to put multiple sensors, actually impossible to put multiple wires into the connector. So PowerWise made this sensor hub, and here's an example of that being wired from the gateway, and then also our multi-sensor with this relative humidity, temperature, and VOC air quality. Looking closer at the sensor hub, it gives 3 parallel runs or runs on the one-wire network bus. So let's say you have one run going to the first floor, and another one could be to the 3rd floor, and the 3rd one could be to the outdoor, for instance. We supply power for various flow meters. We also protect both the gateway and the sensors with various protection here, and we can actually also, if there's unique flow meters that need more voltage, we can accommodate them by adding a different power supply. We have seen a need for both relative humidity and temperature obvious, but also find an inexpensive way to monitor air quality in houses. And that's a very important part when we talk about passive house, when they are so super tight and there's not a true ventilation that average people are aware of. So therefore the skeptics would say, like, how can you have good air quality? So this particular sensor we're using is not a true CO2, but it's a very versatile and very low cost and does the job. So we have a compact device, and for the audience here, can see it's like this. Similar in size and form, just basically we have taken out the air quality control monitor sensor. We have just the relative humidity temp sensors, and in many cases with the passive house, we have one in the living room, sometimes one in the bathroom, and sometimes also one outside as a reference point. So now jumping to the passive house monitoring solution. So just to say that we have just a rough count. I think we have eMonitor solutions with various level of passive house monitoring capabilities. I think we have around close to 50 passive house in North America that are using the first generation solution. And I'm grateful for the great work and a lot of the really defining what was needed from Peter and his experience as a passive house consultant and just being a smart person in general. So we made a solution that not only monitors, all aspects of a house, a passive house, but it's kind of also can almost verify if it qualifies here a passive house. And also, while we have some fancy dashboard and fancy graphs, from a scientific point of view, it collects good data that it's exportable in an Excel format. That's really from where you can do the true, investigation based on your own terms by looking at the raw data. But it can also help the user how he uses his house, and even say that this is a good day for me to do laundry because I'm producing a lot of solar hot water. In contrast to the early eMonitor or the passive house solution version 1, this is a fully integrated solution with the eMonitor, not only from the hardware point of view that we talked a little bit about, but also you can actually, within the eMonitor dashboard, there is actually a button that takes you to the passive house dashboard, so you don't have to leave the eMonitor. It's a clean, nice way of seeing it. Also, you can upgrade to any level. You can upgrade the eMonitor. Let's say that you start with just monitoring the essential things, ERV, the PV production, and various fans and ground source heat pumps. You might have things of nature, but you don't really need to monitor the whole house. You can start with eMonitor 14 and 54. It's very easy to add additional circuit breakers to be monitored. But also, if people want to add extra temperature sensors, extra relative humidity sensors, multi-sensors, weather stations, it's very, very easy, and there's no penalty to. It's pretty much just the difference in cost and shipping costs. So we don't penalize for people for not buying the whole chiller to begin with. We also want to make this as easy to install for everybody, the do's and don'ts. So we kind of want to make a manual and YouTube videos and really sending you a full package all the way from the wiring you might want to get for us, but the crimp tool, the small enclosure you want to hide the temperature sensors in, and so forth. So you don't really need to go anywhere else to us, and you can get a reasonable package to have all the components you need. We will have cut sheet or spec sheet on every single sensor, so you can see the accuracy, flow, temperature, all that. We have been trying to target a sweet spot, we say, including the eMonitor and the sensor configuration, flow meter, and the key sensors for solar hot water systems, and as well we can land on the price under $2,000. And the even though that we can do all this today in terms of we can monitor and we can collect all the data, we can give that in a spreadsheet form today for this particular solution, we're still fine-tuning the dashboards and the full-blown kickoff of this particular second-generation passive house monitoring solution is goal to be at or slightly before the Passive House conference in Denver, where we will have our booth there as well. But it is available it can collect the necessary data. You can get the data, you can put in Excel, and you can make your graphs. Here's just a simple diagram that's showing like what are we doing in monitoring with the hardware. So here we go directly from the eMonitor gateway to the sensor hub. From the sensor hub, here we just show one run where we can have all these temperature sensors basically on the bottom, on the top part, and then we show some of the special sensors like the temperature, relative humidity, and the multi-sensor. In this case, we have a water flow meter and a glycol for the solar hot water system. These are some of the questions that we looked at together with Peter that we like to have answers to, and the system should do it. So, of course, with the eMonitor, native can tell you how much energy each service is using, but from a passive home, it's very easy to understand both in watts and BTU how much it takes to heat and cool the house. And when we talk about the ventilation system in the house, where we say that the many passive house, they have a 1200 watt baseboard electrical heat on the corner of the house, and you want to know that the diagonal bedroom on the second floor also have being heated as well. So here's a way to really understand that is the heating and cooling source giving a uniform preparation of the house in terms of heating and cooling. We have seen HRV systems, ERV systems not being coming well set up from the factory and being using much more power than they should. So here we can see exactly what's going on. Relative humidity, I mentioned that it's good to see that if the fan system can take care of that, both on the bathroom and the kitchen point of view. And also when we talk about the what is the air quality, you can see results of cooking and various seasons and so forth. But, so it does really answer these questions. Some are direct from the dashboard, some is really when you take the data and massage it yourself. Pete, I don't know if you want to add anything to this, but so here's the main dashboard. We'll basically just start looking at the little house there where we know what is the humidity inside and outside, and this is the average temperature and humidity inside. You can actually now press on this. This is not a live dashboard here, but if I press this, I'll have a list of all the temperature sensors in a line graph, so you can see if it correlates to the house. CO2 VOC equivalent, it normally starts at the ground level around 450, and if it climbs up over 1500, it's time to leave the house. So open the window if you can. If it goes over 150, I think actually the bird dies. Yeah, just a simple way to say, like, what are you actually generating in terms of many of these houses have PV. A lot of the things that if you don't have PV or you don't have solar hot water, some of these graphs disappear, and I replace with something else, so it'll just be a screen format automatically depending on how your configuration of your passive house is. And again, are you generating, both in terms of PV and ground source heat pump. I've been told I'm not allowed to say geothermal anymore, so I'll have to say ground source heat pumps. Is that correct, Peter? Good. Solar hot water system, again, it will tell us with the BTU generation, good time to use hot water. The ground source heat pump will have a simple display here. There will be some factors here as well to look at. Here's some pictures of some of the drop-down menus as well, as it goes into temperature. When you have the solar hot water system, you're actually getting a much more elaborate dashboard. Here's some graphs, page. We can talk about it later. But here's the solar hot water dashboard. And it will give you various graphs in terms of these gauges here. Otherwise, it will just be a static image where the temperature will change, and you will have also various graphs that can tell you the production over the last day, yesterday, last month, last week, and so forth. Good. Some of the options, we can add a full-blown weather station that is really plug and go. It comes with its own dashboard as well, called RainWise Net, and very powerful weather station. They actually also now RainWise have made a strong alliance with Weather Underground, and they support this particular configuration. They have something called Rapid Fire. And actually, you can get weather information from the weather station on Weather Underground with 3 seconds delay. So we are working on porting our existing Sony Dash app to an Android-based app, so people that have Android phones will be able to get an app to run on their phone, but we will offer a 7-inch tablet that will come with either a wall hanging mount or also a kitchen counter stand. And the thing is, by having what we do here is that we both communicate with the cloud with the eMonitor data is, but we're also getting some real data directly from the eMonitor. So that will be some energy data there that will be only have a latency of around 3 to 6 seconds, depending, compared to the 1 minute from the online dashboard in general. What's important to mention is that we want to take this to the next level, and one of the exciting part of the eMonitor solution is that you take the eMonitor gateway and you basically look at the back side of it. It has a slot for a radio. It's basically called a Usenet interface. Some thermostats are using that. And we are in process of developing a radio that basically slides in to the eMonitor gateway like this. And even though that when I initially designed the eMonitor, I could see that from utilities and also everybody say that Zigbee is the standard, I can see that it seemed almost to die also from a utility point of view. So not because I'm Danish, but I found that the Z-Wave standard is the most flexible and also very inexpensive. So we're basically making a master radio, and therefore in a very inexpensive way are able to add additional controls for the eMonitor, meaning controls of lighting and receptacles. You can buy these things even made by General Electric, and they remote control outlet and lighting control can be down to like $29, $35. So it's very inexpensive to get these things. So we will add that control, and we will add that control from a dashboard. What I like to see this in a passive house concept is that I could see that there were certain issues where we say, okay, there are blinds, there are shades, where we talk about the passive cooling. We want to have that in effect, and we can have conditions where we can, not for very much money, have these controls of motorized blinds and shades. It also gives, as many other future things, there's more selection of thermostats. You can even have safety, you can have door locks, you name it. So we can go further on and define things that are also controlling on and off of electrical water heaters or other things, air conditions. So that's thermostat, but there's other things that make sense where we can turn things on and off. We're also making a thin rail-based sensor control. So basically, it connects anywhere in the one-wire network to the gateway, and we basically want to have a way where we can connect pretty much any sensor, all the way from a solar radiation sensor to a tank sensor in terms of how much water is in a rainwater tank and so forth. You can see that, this is a passive house solution we're talking about, but there's so many things. The great thing with a passive house is that there's so many other energy low-load homes that are looking to the passive house as a inspiration, and we want to accommodate everybody as much as we can. But this is a way we can communicate with almost any sensor out there for this particular device. We expect also to expand our PV monitoring by offering solar radiation, backup panel temperature, and by that giving some simple calculation based on what solar panels you have of what you should expect of production. And we also have some DC voltage and amperage as well, so we both can monitor what is inverted power and what is going into the inverter, and therefore also maybe see the inverter efficiency. There will be, I'm not quite sure how it will be, but this presentation is available for you in a PDF format. If you contact us, we can give you additional information on the package pricing, more literature as well. I'll hope that you will come and see us at the Passive House Conference in Denver. I also want to thank you for the sponsors that have been part of this and been part not only now but also in the past. And so we have around 4 minutes of questions. I hope that is enough. So Peter, would you be the question coordinator and look to see where that
up on the screen that we can first. Do we have any in-house here, or whether that's working or not? We don't have any there, but does anybody have questions for Carson, Chris?
I have one question. I noticed on the graph that it was the CO2 monitor is really a VOC monitor, and the CO2 is applied from the VOC monitor. How does that work? Not an actual CO2 monitor, right?
No, it's using CO2 reference feed. How do we normally describe this? It's a relative one that basically monitors the changes in parts per million, and the parts per million is kind of based on how a CO2 monitor will react.
Yeah, it's really an equivalent through studies that just shown where they had the true CO2 sensor right next to this, in this case the IAQ engine, but that's measuring VOCs, that they align very closely. The reason we've been using it is because VOCs more aligned with perceived air quality in the space, whereas CO2 measurement would tell us that level, but it wouldn't tell us whether there are odor issues in the house or other chemicals in the air.
So the CO2 might only do CO2. This is actually taking all kind of things that are breathing from paint to cooking and things that doesn't have CO2 in it.
Yeah. And we have, in one particular house where we have a CO2 sensor now aligned right next to this IAQ engine, so we can look at those side by side and see how they indeed track. And we'll be doing that in our next 3 houses as well. Applied Sensor, the IAQ engine has done that as well, and it's shown a really strong correlation between the two in living spaces. But again, just the IAQ engine is more sensitive to perceived air quality in space, is what we are interested in. Ideally, you'd have both in a living space, but we chose the IAQ engine as being a better sensor for this application.
And on that
mind, is some of the sensors also for IAQ also doing control in order to respond, or do you have to manually adjust the HRV?
Right now it's manually adjust, but with the Z-Wave and all that stuff, it's certainly doable for us to do things, turn on a fan or based on the part per millimeter sea level. That can easily be done in the future.
What's the annual fee for the online service?
So the eMonitor is approximately around, I think it's between $12 and $28 a month.
Any other questions? Yeah.
Okay, how does the eMonitor differ from dashboards we'll get with the smart meters?
So the normally with the eMonitor is based on 1 second readings. I think what you can get from the utilities would be maybe down to 15 minutes. And of course, you will have whole house monitoring. You won't have down to circuit level. I know that there's some master plans that in some years you will have smart appliances to communicate with the smart meter and all stuff, but I haven't really seen something that I can see as a true believable path. Also, in general, the utilities do not like to go inside a home, so there's kind of a barrier there already. So,
one of the difference, at least in Vermont, probably other places, the utility data won't be available until the day following. So if you want to do a real-time walkthrough, turn things on and off, you have stuff changes. That's not really part of their use case.
you'll have to take a lot of notes, which is large. And I think that, one thing is the delay, but I also think that if it's every 15 minutes, it's very tough to see a spike,
It's possibly getting home display.
Yeah.
Theory eventually to work the utility meter so you could get real-time, higher speed, but that's a separate path and will be offered for free like that online.
Any other questions? Those to be the end of our time slot here.
Yep. So I'm going to just give Carson a round of applause. Thanks for your time. And still hang around for any other questions. And everyone on the phone, thanks for attending as well. And Carson, his contact information was on the previous slide, and we'll make this information available as soon as possible on the Passive House Alliance website. So thank you.
Right.